Hi students, I'm Satishkumar. In this lecture, I'm going to give the potential difference expression. So this potential difference expression, we actually get it from the work done itself. How we can generally think that how this potential difference is in link with the work done expression, that is work done by the external source. Let us first make a look at the expression for the work done. We know that work done is equal to minus qt line integral. The initial point is b and the final point is a, which is e dot dl, and the units here are joules. But if you observe the units of this electric field intensity, that will be volt per meter, and this dl is units are meters. That means meter, if it gets cancelled, there is a unit called volt, which is the unit of potential. So this overall, we will be getting it as the unit of potential, which is simply v, that is voltage. Okay, now if you apply the upper limit, that is going to become va, minus if you apply the lower limit, which is going to become VB. And that is of course multiplied by minus. It will be either VA minus VB or VB minus VA. Which one will be greater? We'll try to find it after absolute potential, because that will be based on the distance from this center. Okay, distance from this center. Based on that, either VA or VB, which one will be greater? We'll try to see later. But it's very clear that VA minus VB, we call it as potential difference. How we'll be getting that from this work done? Okay, so here work done is equal to minus QT of this entire expression. This entire expression, we are getting it as potential difference. So this is an extra term. This QT, which is a test charge, is an extra term. If we can able to remove this test charge QT, then absolutely we can able to define this potential difference. So what you have to do here is this QT, you have to make it equal to 1 coulomb test charge. So instead of calling it as test charge, here you are going to make this QT is equal to 1 coulomb, and which you send it to the left hand side, that will become W by 1 coulomb of charge. That means we can say this potential difference is the work done in moving a 1 coulomb of test charge from the location B to the location A is called as the potential difference. So here you are actually moving a test charge QT, but that test charge you are going to make it as, or you are going to make it equal to 1 coulomb test charge. Then this test charge, which is equal to 1 coulomb, you are moving it from the point B to the point A, and that amount of work done itself is called as the potential difference. So potential difference is also the work done, but that is the work done to move 1 coulomb of test charge from a point B to a point A. This is what is the definition of potential difference. Okay, first let us make a look at the definition of potential difference. Let us try to write this. It is the work done to move a 1 coulomb test charge, 1 coulomb test charge from a point B to a point A is called potential difference. right? So now I have made this qt is equal to 1 coulomb of charge. This qt you try to bring it to the left hand side. So from this work done expression, what you have to do is w by qt, which is equal to minus integral, this is b to a e dot dl, e dot dl. Now let this qt is made equal to 1 coulomb of charge, and that w by qt, which is 1 coulomb of charge, is now is equal to minus integral from b to a e vector dot product with dl. And this work done on a unit test charge, we call it as a potential difference. And that potential difference here I'm going to denote it by VAB. See here, one thing you have to remember, this representation is of our choice. In some textbooks, they'll give it as VAB, and in some textbooks, they'll give it as VBA. So it all depends on how we represent. VAB or VBA is purely our representation. And what is this VAB is equal to VBA is also what we get actually after simplifying this in minus integral b to a e dot dl. So don't think that VBA is equal to VB minus e VB minus VA, or it is VA minus VB. Okay, just after simplifying this minus integral b to a e dot dl, whatever is the expression that you have to write it. So here I am just representing it as VAB, but in some textbooks he'll also give it as VBA. It's of purely our choice. Now VAB is equal to minus integral, it is from B to A E vector dot DL vector. So this is the expression for the work done, sorry, potential difference from the work done expression, and whose units are, he see here, the unit of work done is joules, and unit of charge, discharge, is coulomb. So we can say this is joules per coulomb, or we know very well that the potential difference unit is absolutely volt. So volt is actually joules per coulomb. So this is about the potential difference. It is the work done to move 1 coulomb of test charge from a point B to a point A is called as the potential difference, and its expression is minus integral B to A E dot dl volts or joules per coulombs. Okay, in the next class, we are going to find out this expression for VAB due to a point charge. That means we are going to write the expression for this electric field intensity due to a point charge, and we are going to simplify it in terms of its distances from the center to the point A as well as point B. That's it. Thank you very much. If you like my videos, please subscribe my channel. Thank you very much.